Welcome back to Brothers in Aerospace and Defense, where we break down the technology, business forces, and real-world decisions shaping modern aerospace and defense. I'm DeWayne Allen, your P&L host.
And I'm Rob Wesley, your technical host. And, thanks for tuning in. And whether you're on your commute, in a workshop, or at your desk, we're glad you're with us. And today's episode really goes straight into the heart of something that captures the imagination of professionals and the public alike. And so that's really how a missile defense system really works without any classified jargon.
We're going to break it down into three simple buckets: detect, decide, and defeat. And we'll explore both the technical mechanics and the business forces that drive how these systems get designed, built, and funded.
But first, let's jump into the newsreel from last month.
Government funding and defense budget and epic fury priorities. In March, the United States government moved forward with the funding agreements that prevented shutdown, keeping federal agencies, including the DoD and FAA, fully operational. But we're still operating under a continuous resolution and not a finalized FY defense budget. That matters because the defense budget is tracking in the, upwards in the 850 to 900 billion range. And under the continuing resolution, programs are held to a prior year spending levels, and that limits the new program starts or any acceleration that's trying to come about. Now, with that constraint, we're seeing targeted plus-ups in priority mission areas. And one of those mission areas is efforts like Operation Epic Fury, which has happened now, which is focused on accelerating integrated air missile defense and rapid operational readiness. From an industry standpoint, that's driving demand across Raytheon, Lockheed Martin, Northrop Grumman, and L3 Harris. So even without a full budget, the funding is being reallocated toward urgent fielded capability. But the risk is still there. Without a full appropriations bill, we could see future funding pressure points later this year. And bottom line, we got some operations that's moving, but with the funding still in the short term, the dollars are flowing towards ready now missile defense capability over long cycle programs. Newsreel 2, commercial aerospace and recovery and supply chain reality. Now let's shift to the commercial side because demand is back in a big way. Commercial aerospace is seeing strong global recovery driven by record passenger demand, fleet expansion across major airlines, growth in international travel, especially in Asia. But there's tension, and the industry is still dealing with some real supply chain constraints. We're seeing Boeing working through its production and delivery challenges, Airbus trying to ramp up the A320 production. And the engine OEMs like GE Aerospace and Pratt & Whitney are continually trying to meet that demand and managing the maintenance and durability issues of what's available in the fleet. And that demand signal is massive. It's a backlog now that sits at about 13,000 aircraft, right? So the demand is strong, and with production keeping up, it's still trying to catch up. And there's a downstream effect of that from an MRO perspective and aftermarket services, and then the pressure on those tier 2, 3, and further down value stream suppliers that's helping trying to get that up the ramp. But bottom line, commercial aerospace has recovered from a demand standpoint, but the execution is still constrained by production and supply chain realities. Rob, what you think about the news this month?
I think supply chain is a big ticket here. And I think, everyone thought that, once we're past COVID, past the tariffs, we have understanding on both those fronts that supply chain was just going to, solve itself. But like I said, it's something that's a reality for everyone across the industry. And that we're all having challenges. And I think it comes down to how we can get our sub-tiers and suppliers where we're performing at the levels that, we were, pre-COVID, pre-tariffs and everything else. So, kudos to those that are still working those problems, and hopefully, best for the future going forward.
Yeah, absolutely. And the supply chain issue that you discussed is also on the defense side as well, right? Same thing. Everybody wants to ramp up. We got all this munition accelerations going on. It's across the board. So, I know, speaking of yours truly, Rob, I know if you got a supply chain somewhere in your work and what you're doing, you're not necessarily sleeping at the wheel here this time.
No, not at this time of year.
Not at this time.
You're usually on the road right now, so you're adding to that that commercial aerospace growth that we've seen. So you're on the road at their supply bases, at those sites, really delving into some of those key production issues or key supplier issues that they're trying to tackle.
So welcome back, and let's get into our missile defense discussion. So let's start with the first bucket, detect. At the most basic level, missile defense depends on seeing threats early and accurately, and you can't stop what you can't detect. Rob, break it down for the audience.
Yeah, so when I look at the technical foundations of detect, there are three really main detection layers that I want to focus on. First being space-based sensors, second being the ground-based radars, and third being the airborne or maritime platforms. So when you look at the space-based sensors, they're satellites equipped with infrared and optical sensors that really watch the Earth's heat signatures, but they're often the first to spot a launch. The ground-based radars, these are those high-powered radars that track objects once they enter specific coverage zones. And you can really think of them as precision tools. And they really redefine data after satellites cue them in. And lastly, the airborne and maritime platforms, these are those long-range radars on aircraft or ships that help extend the view where the fixed ground radars really can't reach. And some of the key tech concepts to really truly understand this topic is really signal processing. So that's the raw sensor data that doesn't look like a perfect crack. Then the algorithm's really clean and intercepted. Track initialization. So that's determining whether a track is a threat versus a benign object. And then lastly, data fusion. That's combining the multiple sensor feeds to create a reliable picture of the battle phase. But DeWayne, can you walk us through some of the business perspective on this?
Absolutely. From an industry standpoint, the detect layer is one of the most capital intensive, strategically important parts of the missile defense, right? This is where governments spend very heavily upfront because early detection buys time, and in missile defense, timing and time is everything. And so now what you want to look at is who dominates the space from a mix of traditional primes and highly specialized sensor companies, right? So you got the space base that goes with the space-based sensors, right? You got the key players are like Lockheed Martin, and they have the next generation overhead persistent radar program, right? And that's been going on for a while. Lockheed Martin has the SBIRS, or the space-based infrared system, the Constellation, right? And these systems have been typically take 7 to 10 years to actually get to some deployment, and which is important because it tells you this is not a fast turn business. These are long cycle, high barrier to entry programs. On the ground side, you got companies like Raytheon that's got the ANTP2 and the Patriot radar systems. Lockheed Martin has the long range discrimination radar, and and these take around 6 to 8 years to get to operational capability, and they're valued $1 to $2 billion. But the bottom line is the detect layer is a multi-decade investment cycle anchored in national security with global demand and extremely high barriers to entry. And every year, if you really tracking the defense budget, right, Rob, it's always an upgrade to these systems because they already are existing in space. So you got to get up there, get another sensor up in space, either add, upgrade, take a piece of the constellation. So SBIRS has been. I remember SBIRS when I first started in industry. This is, over 27 years ago, right? And so it's just, it's really critical that we understand that these are long range programs, right?
Yep, absolutely. And then they're not going away anytime soon. So that's something that you continually build on for the future, because like you said, as missiles evolve and innovate, these same sensors that need to really detect them need to evolve as well. So now we're going to jump into the segment 2 of our show today, which is decide, which is that command and control. Detecting a threat is step 1. Now you have to try to decide on what to do with that information, and really some of the technical foundations on what to do with that foundation is really, this is where C2 is command and control systems really live. And think of C2 as the brain of the defense system. Some of the core foundations for that brain is really around threat evaluation, course of action generation, and also engagement authorization. So really around threat evaluation, that's really how you prioritize what tracks are going to be the most dangerous. The course of action generation is where you, for each of those tracks that you identify, you actually have to intercept vectors as well. And then the third being the engagement authorization. This is where this can be automated or human in the loop, depending on the policy and the threat type. Coming out of those three foundations are really core important concepts that I want you guys to really take note of. First being the battle management software. So that's where it integrates tracks, options, and rules of engagement into a decision layer. The second being a latency management. So that's really that time between decision and the detection. And really shorter is the better on that end. And lastly being resiliency. So that's where systems must remain operational under degraded communications or contested environments. DeWayne, can you really walk us through how we look at this from a business perspective?
Yeah, I can. So now when you move to the decide layer, this is where missile defense shifts from hardware intensive to more software integration and system engineering dominance. This is also where the AI and AI ML is also going to be incorporated into the architecture. And this is where the competitive landscape becomes very interesting, right? The key primes in this include, Northrop Grumman again. They have the Integrated Battle Command System, or IBCS. Lockheed Martin got the Aegis Combat System. That's all across everything that's on water, right? With Aegis, right? And then of course, and Raytheon's got the fire command and control systems that go activate the energy on the target. And so let's just take a look at the Northrop Grumman IBCS system, right? It's valued around $3 billion. It's been in development for over a decade. It's actually in full development operational capability over a decade. And the core capability for it is integrating this multiple sensors and shooters into a unified command network. So just think about it's taken with software and integrating and system engineering and giving it an ability to do those core functions that Rob talked about across multiple different radars that come from different parts of the industry. But also, it's also talking to the shooters, the effectors of what you want to do on that command. So it's very critical. It's important. And the warfighter is central to this. This is where the warfighter is really doing the work, right, in between for doing that things. And so what makes it, powerful, it breaks down the stovepipes between those different systems that we talked about. And instead, each system operating independently, one radar can queue to another system, one interceptor can engage based on another sensor. And this is where companies win the long-term advantage. So once you have the software that can integrate across the entire architecture, you become valuable, extremely valuable, because you're difficult to replace, you're central to upgrades, and it's critical for interoperability. And what that creates is the stickiness. And if you're in business and if you're trying to get market space, you stay sticky, they have to come to you because you got the integration, you get those costs right. So bottom line, the decide layer is a software driven integration heavy type business where winning that software architecture means owning the long-term value of the system. Before we jump back in, please hit subscribe on your podcast platform, right? It helps us continue to bring this content to you. We really appreciate it. And if you prefer watching this on YouTube, please hit the subscribe button there. You can watch the full video version. As always, hit like and things like that, and comment and share for what you see with your friends. We really appreciate delivering this content to you. This is a way for us to know that we're giving you the right things that you want to hear. So let's get into the next segment, defeat. And it's all around the kill chain, the execution of that kill chain. And this is what people picture when they think about missile defense, that interceptor or that energy on target or that kinetic kinetic action, and what we refer to that as defeat. And Rob is going to run us through the technical fundamentals of that.
Yeah, thanks, DeWayne. So yeah, this is where you see those missiles on gifts or things like that. But we'll break it out from a technical standpoint. So there are several key mechanisms in the kill chain. So first being the hit to kill interceptors. So these are those really precision weapons that collide with the incoming threat, like a bullet hitting a bullet. Second being the directed energy concepts. So these are those still R&D heavy, but still these are those lasers or high powered microwaves that aim to disable threats without even a physical collision. And third being that those decoys and jammers. So sometimes winning actually means confusing the threat and not actually hitting it, especially in those context silos of war as we think about it. Some of the key concepts that I want you guys to come away with is within this kill chain is guidance control. So interceptors must use sensors and an autopilot to steer to intercept at a point. And then you have proximity fusing, which is what determines when you detonate or activate. And lastly, being testing and validation. This is where it takes a place in the instrumented ranges and simulation environments for safety and repeatability. DeWayne, I know it's a lot to talk about from a business perspective on this, so let us know what you think.
Yeah, I mean, I spent a lot of early in my career really working on this type of stuff, so it's really real, and the economics behind it is real, both from both perspectives, right? So, but unlike software, every intercept has this thing we call physical cost per engagement, right? And a cost per shot. One of them is, we call this thing cost per shot economics, right? So these are not cheap bullets, right? Unit cost drive strategy, and how many missiles are on standby, what mix of kinetic and non-kinetic systems that you got to use. And then with that cost per shot, the economics or cost per kill, you might hear it a bunch of ways. This drives scalability of these, how many missile systems that you need, right? It causes suppliers to scale manufacturing without trying to compromise quality and schedule. And it's always a procurement concern. And then once you have, some type of plan on how you're going to scale or why you're producing these things, then you got to do this support of things that's out there, right? You got to train, have some maintenance, you got to do the upgrades to it, you got to do a obsolescence management. And these are all revenue streams or cost centers, which you're looking at it for, the major defense contractors when you think about it. This is critical when you hear a lot about in the news and in your readings, when you think about what's happening today. It's like, hey, the cost per kill for this mission is, way too high versus what the threat is. And so it really is important that we figure out what type of energy on target that we're going to put on, what type of action it's going to take. So because you want to really drive that cost, right? And some of the OEMs that are engaged in this is, the Raytheons of the world, and Lockheed Martin and Boeing, all the, the big hitters. You got systems like the Patriot, Standard Missile 3, Standard Missile 6, the THAAD interceptors, and the ground-based interceptors from Boeing as well. And these are strategically important systems that protect not only us in the U.S. but our allies worldwide. And like I talked about earlier, it's about how do you balance that cost per shot versus what biggest a threat, right? So we have that actual issue that's happening right now. You don't want to use a $10 million missile interceptor on a $50,000 drone, right? and it causes all kinds of permutations throughout when you in these situations. And then even on top of that, right, you got these procurement strategies that are critical to that as well, right? You got to focus on, you got things like, we're not only doing the cost shot per threat level, you got to look at layered defense, right? You got to see what the mix of the systems you're going to be, and then how you're going to optimize that from an inventory perspective. But bottom line, the defeat layer is where the unit cost meets the operational urgency. and it directly shapes how defense strategies are executed. And because of it's, I like to call it, it's the part where you're dealing about the boom. This is where you'll see media and everybody's really got that energy on it to link about it is. But and so it's critically important that you understand, and that's why we're here today to help you with understanding the overall mission of what it takes. But the Intercept is just a part of it. It's the meeting. It's the like we like to call it. It's the beer pot in the beer can, but you can't have the beer without without everything that goes with it, right?
Yep. And DeWayne, I got one question for you. So, as I'm thinking about like you saying the threat level of a drone, how does I know the big thing in the industry right now is like focused on low cost attritable platforms and vehicles. How does that really play into confusing the threat value of enemies or for the fleet? As part of this strategy for war.
Yeah, that's a great question. Essentially, if we can find a considerable match that lowers your cost per shot to affect that threat, it makes it more easier to actually get to these to meet the mission first of all. But also it drives a whole new industry that's been going on last, and Rob, me and you have been living it last 5 years, where it's like, hey, we got drones that are just dumb bombs that can fly, that are heavy, and they're coming down and they're just using kinematics to go blow up something. But it's so many of them, and they're made at $25,000 a clip. It's easy. What that's creating is, hey, can we use a drone with a drone, right? It's also creating a market space where you're trying to figure out, how can I see these very inexpensive drones, because they're usually coming in some swarm type threat. It's like, it's not just one, it might be 100 of them in a threat. And how can I put effects on that swarm of drones? And so you need the attributable things where, hey, maybe I can, if I see some things coming, I got to do multiple things to attribute to that. And you want it to be low cost. I might, throw some drones that says they're the hand push and turn them on, and they can go and knock them out as they come and descend into the targeted area. I might have some, laser guided systems that's putting energy on one of those 100 drones that's in that swarm. I might have some sensing or ISR type product that's sensing and seeing as many, and maybe I can shoot them from the ground or shoot them from up. Or I might, and this is where it gets expensive. If I have to go use a jet, F-35, and use that expensive payload, go back to our last episode and talk about it. Like, I use that payload to take that drone down. It's, that cost per kill goes way high compared if I'm shooting off an F-35 setup, just throwing something from the ground, or automatically I see it, right? So that defeat layer it is trying. That's a great question, Rob, to go with. It's a great question.
All right, so segment 4, this is really putting it all together. So we're going to talk about architecture and operations. So what we've got is detect, decide, and defeat. But we want to talk about how they all work together. So from a technical integration standpoint, you have the sensor networks and the data buses that ensure all the parts are shared on the common picture. And you have the reference clocks and the timing that keep that data synced between space, ground, and mobile systems. And then lastly, you have the resilience and redundancy that are built in, but you can't lose a node and still maintain that coverage. And when you think about it from an operational doctrine standpoint, you have deployment concepts that really vary by region and then also by threat. And then you also have rules of engagement governed by how much of these automated decision loops interact with the human operators. And then lastly, you have the joint and coalition forces that increasingly share that data. So you have that added complexity and also capability that you're bringing to the fleet. DeWayne, what are from a technical standpoint, that was it. But what from a business impact standpoint can you talk about more?
Yeah. From a business aspect is more of, the systems are sold as architectures, not components. And so this benefits integrators, right? You just don't buy a piece of something. You buy a piece of something that can connect to something inside the architecture that you have. Governments don't buy the pieces. They want to make sure that, and what that means is, I have the ability to connect to the networks. I can use not only, the network connections via, some Ethernet cable or some data buses or connectors that can work with, but the timing and those things are synced accordingly to what the system is going to be, because it'll throw the whole system off if it's not connected, right? And then from a life cycle perspective, the contracts that come out of this from a business perspective comes out in sustainment and software refreshes, provides some long-term revenue that keeps that train rolling. So if you're in the system architecture and the integrator space, and you can, how to manage and deal and be an integrator, you got to master not only one of the levers, but all the data and the sharing and all that stuff that happens to make sure the whole system works, right? So you have long-term life cycle, if you will, and it's got long-term revenue, and that those cycles are long, right? And then also, this is from a business perspective, this is also important while we have international partnerships and foreign military sales. They also expand this opportunity. But, you're going to have some compliance issues, obviously, that are applied to that because of, the type of the level of capability that you need to have. But these things, the architecture and the operations of these things still matter. And operations from a FMS perspective is, hey, I got to go pick allied country X and their military and how to operate these things. But I got to make sure that, they got to do it in a language that they have. And I have to, do the sustainment and the software at the right capability level that's agreed to by the governments themselves, and then keep a maintenance aspect of that. But what's critically happening now, particularly on the international side, our allies are trying to keep do a lot of localization activity, by which they're developing their own capability, and we're partnering with them to have them go, hey, let's work, and you can build a part of the integration, right? You and use your in country expertise to go build and develop that, so you can maintain that on your own. So that's another opportunity as well of what we're doing from that perspective, right?
Yeah, absolutely. And I think one thing I want to foot stomp you, DeWayne, about is really the systems sold as architectures. And I think that comes down to like the networks being interchangeable between all the various forces. So you have Air Force, Navy, Space Force, and all the others, that all this needs to work interchangeably between. I think, the people and the business that really solve that network problem is really going to be the true integrators of this new age AI ML environment that we're all living in right now.
Agreed. So, let's talk about why this entire system matters, right? So let's bring it up and just look at it strategically, right? So, we kind of simplified the missile defense into 3 core steps, right? You got the detect, decide, and defeat. Detect is all about seeing the threat early, using satellite radars and sensor networks to identify and track a launch. The decide piece is the C2 layer that we like to call it, C2 being command and control, where the software and the systems and operators analyze, determine if there's a threat, and figure out what's the best response, be it kinetic or non-kinetic. And then the defeat is the intercept phase, where the defense systems like an interceptor, missiles, or any countermeasures actually stop the incoming threat.
And then I think one big takeaway that I have from this episode is really that a missile defense layer isn't just about the interceptor. Most of it is really about the complexity that actually lives between that detect and decide layer. So that's where you have the sensors, the data fusion, the command systems that make fast decisions possible for everyone. So if those systems really don't work seamlessly together, the entire defense chain breaks down.
Yeah, exactly. And from an industry perspective, missile defense is one of the best examples of a globally based, large-scale systems integration in aerospace and defense. I mean, you got satellites, radar, software platforms, interceptor, communications network, CENTCOM, all kinds of things all working together across multiple organizations, both industry and all the services and suppliers that are engaged involved in that.
Absolutely. And I think that's what really why this topic really matters the most for the industry. These systems drive innovation in areas like advanced sensors, AI enabled command systems, and high speed data processing. And those technologies often spill over into other areas of aerospace and defense programs.
And so when you hear people talk about missile defense, just remember that simple framework: detect, decide, and defeat. And once you understand that, the whole architecture starts making a lot more sense.
Yeah, and it also shows how many different roles across aerospace and defense contribute to these, making these systems really work, from engineers and software developers to program managers and also supply chain leaders.
Exactly. And it's what makes this industry so fascinating.
Okay, so if you enjoyed today's conversation and want to deep dive into things like this across aerospace and defense technology, make sure you're subscribing to Brothers in Aerospace Defense whenever you listen to our podcast.
Yeah, and go ahead and search Brothers in Aerospace and Defense on YouTube, hit subscribe, turn on the notifications so you don't miss any upcoming episodes. And even we got some special, another special series that's coming out as well, where we interviewing leaders across the industry.
And if you found today's episode helpful in understanding missile defense a little bit better, really share it with a colleague, a friend in the industry, or someone who's curious about how these systems actually work.
Yeah, we appreciate you listening and learning and growing with us as we continue to explore the technology business in the future in aerospace and defense.
Until next time, keep pushing the boundaries, keep asking questions, and we'll see you in the next episode of Brothers in Aerospace and Defense.